Good day, students. Once again, we ended here from the previous recording, and I always play with you that you watch all the videos in the order of my recording or in the order of the examples that I'm doing, because you might miss something somewhere if you don't listen to them in that order. Then after you've listened to them for the first time, all of them in the order that I'm recording, then you can choose to listen to anyone that you want to listen to at the time of your revision. That's not a problem, because you would have understood my foundation and the chronology of my teaching. Now, thank you very much once again. There were so many notes or note to be taken under this nominal and effective. And one that I want to end with is the one that said, or start with the one that said, the more often is interest compounded, the higher the effective rate, even though the nominal rate is the same in each case. And we have explained that in details, and we have done different examples or different scenarios in example 3.8, where we saw that the interest was increasing and was increasing at a rapid rate that I don't know what rate was it, but it was increasing because the number of compounds in a year were also increasing. So we discover that the more often the interest rate is compounded, the higher will there be effective rate in comparison with the nominal rate of interest. And that was the conversion. If you remember, we're busy with the conversion, converting this interest rate with our previous calculation. Now we are done with the conversion. Now we are going to the example, which is our current example, which is example 3.9. And in example 3.9, there's a very important note that I want to bring to your attention, and this note will be very applicable to this example in terms of application. The note is below the example, but is supposed to be above the example according to my point of view. Hence, I'm starting with this note. So put it above the example as kind of introductory theory to 3.9 example. It says the nominal rate, which we know that the nominal rate is the advertised rate. I want to highlight that. The nominal rate, which is the advertised rate, is the rate that is used in calculating the periodic interest: monthly, quarterly, half yearly. Remember, it's only three. We can have 2 monthly, we can have 4 monthly, we can have daily. So in other words, it's just that there are different number of times at which the interest will be compounded when it comes to the nominal rate of interest. Then after we now go to the second note of the notes, says the effective rate is equivalent to annual rate. And I want to highlight this very important notes, because I will be applying them in this example, and I would like you to apply them in the exercise that follows after this. I think exercise 2.4 or 2.5 or something like that, but I will show you that one now. And I want you to come back here to this note and other notes that I've spoken about, and make sure that they are in your mind and you are applying them to the scenario that you'll be dealing with at all times when necessary. Now, when we answer our question, we need to be aware that when we're calculating our nominal rate is monthly compound, 2 monthly compound, quarterly compound, half yearly compound, daily compound, and 4 monthly compound. There are different number of compounds. But when it comes to the effective rate of interest, it is an annual equivalent. So it is the rate for the year, or a rate that is equivalent to an annual equivalent, of which in the previous scenario that we dealt with, we had in the first one it was 6.09%, our effective, which was annual equivalent, which was equivalent to the nominal rate, but it was higher because of the number of compounds. It says in 3.9 that we compute the nominal and effective rate of interest. Now remember, we are not converting. In the previous scenario, we were doing the conversion, and we're converting using the formula, and we did our conversion very well, and you're very clear with that. We converted based on the number of compounds from number A up to number D. In this case, we are not doing the conversion. We are just calculating the nominal rate, but we need to have at the back of our mind an effective rate. We need to have at the back of our mind the theory that nominal can be monthly, quarterly, half yearly, or any number of compounds in a year, but the effective must be an annual equivalent. Please be mindful of that. It's very important, but I will do link this theory as I proceed with this question. Now, what are we given? We are given S, which is sum accumulated, and in the previous recordings I said future value, and this is present value, and I prefer that. What are we calculating? We are calculating the interest, which is the nominal and the effective interest rate. Our n, which is n being the number of years, n in this case is 2 years and 1 quarter, which is 1/4, and n in the second scenario it is 30 months, and I want to convert both of our years to become month, because 2 years we know that it is 24 months, so 24 months plus a quarter, because we know that a quarter is made of 3 months, therefore now that means this 2 years and something, it is 27 months in other words. And I want to convert the 30 months divided by 12 into years. Therefore, now that means the 30 months is 2.5 years. Then you're asking me, why, Andile, are you converting this? Is because in the exam you can be given information in any manner. You need to know how to work your stuff up and down. It doesn't matter in which way. But I will still answer the question and explain both sides of the story. Now, very important also to highlight is the fact that your M, which is the frequency of times the interest is compounded in a year. For the first scenario, it is monthly. The second scenario, it is quarterly. I'm not focusing, guys, on other numbers. They are just given numbers, but I want to focus on the main core of information that need to be analyzed and unpacked very well. Now, meaning the minute it is monthly and quarterly, it means we know that it will be compounded 12 times a year. That means it will be 12 times. This will be 4 times a year, because there are 4 quarters in a year. Now, let me then erase what I've done, but we know at the back of our minds this is 27 months, and we know at the back of our mind this is 2.5 years. Just there at the back of your mind. Keep that one while I'm erasing it, but keep it there. It's very important. Now, what are we required to calculate? We're calculating nominal, which we know that our nominal is monthly compound, quarterly compound, half-yearly compound, and daily compound. But for effective, is an annual equivalent. I'm highlighting this, guys, because it is very crucial. Now, let us go straight to our calculations, and I will use the financial calculator, but not the one which is in the app, for some reason, because there's one thing that I discovered that will not easily make sense when I'm explaining using the calculator, which is the financial calculator, and it will not be consistent with my calculations. Now, how much do we have? We have under A future value 1256. We have under number A future value, which is 1256. FV, we have our present value 1050, present value plus or minus. It doesn't matter most of the times which one you put as negative, but present value can also be, and future value can be plus or minus. We have 1050, but one of them, which is present value indicating outflow of cash, preferable, must be negative. We have our n. Our n is 2 and a quarter, 2 years and a quarter, 2 years and a quarter, And 2 years and a quarter, we know that a quarter is 1 over 4, then 1 over 4 is 0.5, therefore now plus 2, therefore now that means in years this is 2.25 years. So now if we say it's 2.25 years, then you say it will be 2.25 years times by the number of compounds in a year, which is times by 12. So if we term this by 12, how much do we get? We get 27. Hey, do you see that we get 27? Why do we get 27? Because there are 27 number of compounds in 27 months when the compounding is on a monthly basis, which is the case here. So that means if we were given information which is here n as 27, if this was 27 as I wrote before, then you could have said 27. Then you say how often is it compounded monthly? How many months are in 1 month? It will be 1. So 27 divided by 1 will still give you 27. Then after, what are we computing? We compute our I. Now because our M is compounded monthly, our interest will be per month. I want to repeat that. Because our interest is compounded monthly, then our interest will be per month. And if you look at our N is per month, meaning the number of compounds for the entire period, but on a monthly basis. So now because our interest is compounded monthly, then our I will be per month. Then we need to multiply this by the number of months in a year. And I can go back now to the first scenario that I explained to you, where I said when you're calculating I, if you remember in a formula, I said when you're calculating I, there was a formula that says 1 plus 0.15 divided by M. If you remember that formula, it's also similar to the one that we dealt with. That means our interest is divided by the number of times the interest is compounded in a year. So now, in other words, if we say, I think that was in a formula, to be honest, if we say 15 divided by 12, then this will give us interest per month. So now we need to get our interest before it was divided by M, in other words. So the answer that we get, it is after we divided by the number of compounds in a year. But now we need the interest before the division of the number of times of compound in a year. And I did highlight that in one of the questions in my compound interest. Hence, please go back and listen to all the compound interest questions. You will see that I explained this very well. And then now, whatever answer we get, we need to multiply it by 12. Then we go to our financial calculator. And I said I don't want to use the app. It will give me the correct answer here, but it will not allow me to explain what I want to explain. But I will show you. I will show you now. Now it says we say have 1256 is the future value. We have 1050 plus minus 1050 present value. We have 27, which is N. We compute interest. Now when you say compute interest, what you will get before you multiply, when you say compute interest, you will get 0.665694494. Then you multiply this by 12. When you multiply this by 12, you get to 7.988 929. So now this will be our interest per annum. So this will be our interest per annum. Then this will be our interest per annum. And please highlight the fact that we need to multiply our interest by the number of compounds in a year whenever you're calculating interest, by the number of compounds in a year. And once again, this one is the nominal. This is nominal rate of interest. Then now still under number A, we need to calculate the effective rate of interest. We need to calculate the effective rate of interest. Nothing changes we still have the same numbers, 1256 present value plus or minus 1050, sorry, is the present value, that one is the future value, and our n now will have to be 2.25 years. Then we compute our interest. Now the question is, why, Andile, are you not multiplying here by 12? Remember, if I multiply by 12, what is 12? 12 is the number of compounds. 12 is the number of compounds in a month. Sorry, the monthly compounds in a year is compounded monthly. I cannot multiply by 12. Why? Because the effective rate of interest is an annual equivalent, meaning I need to take my n as in years. My n must be in years, not based on the number of compound. The reason why previously I multiplied by 12, it is because we were calculating our nominal, and our nominal is monthly, quarterly, half yearly, or daily compound. Take note of that. Is when the interest is calculated for the period on a monthly basis, quarterly basis, or yearly basis. But the effective rate is an annual equivalent rate. So now we need our n to be in years so that our interest will also be in years. When our n was based on the number of times the interest was compounded, then we got interest which was per month. If you remember in our calculations, the figure that I put here, that is 0.66, that was per month. Why? Because our n was per monthly compound in the entire period. So hence we had to multiply by 12. But in this case, our n must be in years so that our interest will also be in years. Why interest to be in years? Because our effective rate of interest is equivalent to an annual, meaning yearly equivalent. So we need our n to be in years so that our interest will also be in years. Then we do the same thing. Now we say second function alpha 0, 0. We have 1256 future value plus minus 1050 is our present value. 2.25 is our n. Then we compute our interest. Then when we compute our interest, we get exactly the interest rate of 8.2874 to 874 000067% per annum. Now take note again, n becomes very important. N was per month because our interest was compounded per month. Now because our n was per month, our interest rate that we got as an answer was per month, and we need to multiply by the number of months now in a year, which is 12, in order for us to get now our interest for the year compounded monthly. But this is our advertised nominal rate of interest. That was number A. Then now we go to number B. Now let us look at number B. What do we have in number B? Number B, again, in number B, what are we calculating? Remember the requirements. We are required to calculate the nominal and the effective. Calculate the nominal and the effective rate of interest. That means when we're calculating the nominal, we need to take into account the number of compounds, which is quarterly, meaning our n must be in quarters. So in other words, we need to say, if we have 30 months, how many quarters do we have in 30 months? Take note of that. How many quarters do we have in 30 months? Therefore, now we need to say divide by the number of months in a quarter. If your answer is in, if your n is in month, we need to say divide by the number of months in a quarter. Why so? Because the quarter is 3 months and our n is in years, very important. So we need to divide, so our n is in month, we need to divide by the number of months in the compounding period, or the number of months in a quarter. So if we do so, it will be 30 divided by 3, then this gives us 10. That means in this case there will be 10 quarters in 30 months. Or else you could have said 30 divided by 12. Remember I said we could have been given here 2.5, meaning 2.5 years. This could have been 2.5, meaning 2 years and 6 months, because 2.5 is 2 years and 6 months, and 2 years is 24 months. 24 plus 6 is equal to 30. That is why it's 2.5. So now in other words, that means 2.5. We could have said if it's 2.5, 2.5 times by 4. Why 2.5 times by 4? Because our n is in years. We need to multiply by the number of compound in a year, which is 4. This will still give us 10. Let's verify that. 2.5 times by 4, we get the same 10. So now, be it you are given numbers in years or given numbers in month, or n in years or n in month, it does not matter. But have at the back of your mind the knowledge that when my n is in years, I multiply by the number of times the interest is compounded. But when my n is in month, I divide by the number of month in the frequency, which is our m, in the number of month in the number of month in a monthly in the compounding period, which in this case our compounding period is quarterly. Therefore now that will be how we deal with this one. Let us then now go straight to our calculations. First of all, what are we calculating? Nominal rate. So we're calculating nominal rate of interest. And our nominal rate of interest, we have our future value there first. Future value of how much? Future value of 19,000 and 17.5 present value. Future value of 19,000 and our present value, it is 17,500 plus minus our n. Remember, our nominal, it can be monthly, it can be quarterly, it can be whatever period it is. Therefore now we need to make sure that our n is per quarter. Our n must be per quarter. Why? Because our interest is compounded quarterly or every quarter. So our n will be 2.5 times by 4, or 30 months divided by 3, which at the end of the day our n becomes 10. It doesn't matter which one is which, we get to the same number, 10. And I remember I converted this 30 divided by 12, it gave me 2.5. I said 30 divided by 12, it gave me 2.5 years. Times by the number of compound in a year, which is 4 quarters in a year, we still get to the same number, which is 10. Then after we say compute our interest, and we know that the interest that we get will be per quarter. Why? Because our n is in quarters, hence we divided by 3 here, because 3 is the number of months in a quarter, which is number of months in the compounding period, in this case being a quarter. So meaning now we're saying our I that we get, we need to multiply by the number of quarters in a year, and there are 4 quarters in a year, so we need to multiply this by 4, whatever answer that we get. So now let me do the calculation on the side. And the calculation on my calculator, don't forget second function alpha 00, we have 19,000 being the future value, plus minus 17,500 present value. Then we have 10 as our n, we compute our interest. Then now after we have computed our interest, the answer that we get, I want to show it also, let me show it here. The answer that we get is 0.82577182.3. This is the interest per quarter. Interest per quarter, or interest per 3 months. Remember, a quarter is 3 months. interest per 3 months or per quarter. So now if this is per quarter, we need it for the full year, but we know that is compounded quarterly. We're not ignorant of that. We know that is compounded quarterly. Why our interest is per quarter is because our N is per quarter, is converted by the number of quarters. It's not per year, it's per quarter. So now that means whatever answer that we get here, it need to be multiplied by the number of quarters in a year. So now hence in my calculator, I'll just say times by 4. Then I get 3.30 872.94% per annum and compounded quarterly. So now that will be our final answer. Then after we go to number B, where we're calculating the effective rate of interest. Effective rate of interest. And we know once again that the effective rate of interest is the one that is annual equivalent, meaning our N must be for the full year, must be in years. So we have our 19,000 rands, which is the future value. We have our present value, which is 17.5 plus minus. Our N must be in years, and we said now for N to be in years, we need to say 30 divided by 12, which is 2.5 years, meaning 2.5 years. You can just punch 2.5 N or 30 over 12 N. It does not matter which approach you use. But as long as at the end of the day your N is in years, not your N is in quarters. Because quarters, monthly, or any compound are for the nominal rate of interest. We compute our I, then our I will be in years, which is annual equivalent. And effective rate of interest is annual equivalent to an annual rate. 19,000 rands is the future value, 17.5 plus minus present value, 2.5 is our N. Then we compute our interest. Immediately you get to 3.344 3.344226943% per annum. This is done and dusted. This is the difference, guys, between effective interest rate calculation and nominal interest rate calculation. What is very important and will be a reminder for your lifetime is the fact that the nominal, make sure that your N is either per month or per quarter or per 6 months. Make sure that your N is always per that. And how do we do that? We said to multiply here by 12 to get it per month. We said here 2.5 times by 4, and we got 10, which was per quarter, which is again 30 over 3. It gave us 10. This is per quarter. And at the same time, to keep it for the full year, we just divided by 12 in the number of 30. Thank you guys very much. You've been wonderful once again. The next recording will be probably 2.4. I was thinking of doing that, but I don't think I'll do it now. The next recording that I have spoken about before is the conversion of the nominal to an equivalent nominal rate. This is the very lovely. Now we are converting nominal into nominal. Then the question, how do you convert nominal into a nominal? Then wait for the next recording of me, where I will be introducing you to this simple formula that you don't have to worry in terms of how to derive it. You just have to memorize it and be able to paste numbers where they're supposed to be pasted. It's a very lovely conversion, converting nominal into nominal equivalent. And remember, previously we converted nominal into effective. Know that calculation, and also please know this calculation, because both of them are distinct and they are part of your exams. Thank you very much.